Today, we're going to dive into one of the most complex manufacturing challenges on the entire planet, and we're going to meet the invisible guardians that make our digital world even possible. Let's start with a number, 170 billion. That's how many transistors can be packed onto a single, top-of-the-line computer chip. It's a number so vast, it's almost impossible to even wrap your head around it. And, that scale creates an absolutely monumental challenge. If just one of those billions of little components is off, the entire chip could be useless. So, how in the world do you find that one tiny mistake? How do you even attempt perfection at that scale? Well, the answer comes down to two critical guardians, a two-step process that's actually easiest to understand with an analogy. Think about building a skyscraper. First, you have verification. This is like going over the architect's blueprint with a fine-tooth comb, checking every single detail for flaws before anyone even thinks about digging the foundation. Then you have testing. This is like walking through the finished building and inspecting every single brick, every wire, to make sure the construction itself was done right. Let's start with that blueprint. This first guardian, verification, is all about getting the plan perfect. It's about making absolutely sure that blueprint is flawless before it becomes a physical thing. So, what is it really? Verification is the whole process of making sure a chip's design, the digital files, the blueprint, works exactly like it's supposed to. We're not talking about silicon yet. This is all happening inside a computer, checking the instructions that will one day go to the factory. To do this, engineers basically ask three giant questions. First, function. Does the logic of the chip actually do what we want it to do? Second, timing. Is it fast enough? Will the signals get where they need to go in the fractions of a nanosecond required? And finally, physical. Can a real factory with real machines actually build this thing we've designed? Now, to answer that big question about function, engineers have two main tools. On one hand, you've got simulation. This is where they just throw millions, even billions of virtual test cases at the design to see how it reacts. It's like spot checking the blueprint. It's fast, but you can never be 100% sure you checked every single possible scenario. But on the other hand, you have formal methods. And this is just incredible. Instead of spot checking, it uses pure mathematical logic to prove, with a capital P, that the design is correct for all possible inputs. It gives you total certainty. But as you can imagine, it is computationally intense. So let's say the blueprint has passed. It's been verified, it's declared perfect, and it gets sent to the factory. But the job is far from over. Now, we have to actually inspect the physical product that comes out. And this brings us to our second guardian, testing. Unlike verification, testing is all about checking the real, physical chip that's been made. We're now hunting for tiny, physical flaws that might have snuck in during the manufacturing process. And this is so crucial because even if you have a flawless blueprint, things go wrong in the real world. A single microscopic speck of dust, a tiny fluctuation in temperature. It can create a short circuit where two wires that shouldn't touch do, or an open circuit where a connection that should be there is broken. And this reality leads us to one of the most important words in the entire chip industry, yield. Simply put, it's the percentage of good, working chips you get from one of those big, round silicon wafers. For a manufacturing line that's been running for a while, a 92% yield is considered pretty solid. That means for every 100 chips you make, about 92 of them are perfect and ready to go, while 8 have some kind of defect and have to be tossed. But here's where the story gets really weird and a little counterintuitive. The final yield isn't just about how many defects you have, it's about where they are. The pattern of defects across the wafer can make a huge difference. Okay, check out this first scenario. We've got a wafer with 34 individual chips, or dies, and on it there are 10 random defects, just scattered all over the place. Since each defect kills a different chip, we lose 10 chips. That leaves us with 24 good ones, for a yield of 71%. Now, look at this second wafer. It has the exact same number of defects, still 10. But this time, they're all clustered together. Since some of the chips get hit more than once, the total number of ruined chips actually drops to just 8. That leaves us with 26 good ones, and our yield jumps up to 76%. And this shows us a really critical point. From the manufacturer's point of view, it is much better to have a few chips that are completely riddled with problems than to have a lot of chips that each have just one small problem. It's a fascinating bit of industrial statistics. So, if you know you're going to have to inspect billions of transistors on a tiny piece of silicon, how do you even start?
Well, the smartest engineers actually plan for the inspection way back at the blueprint stage. There's this brilliant concept called design for test, or DFT. While they're still working on the digital blueprint, engineers intentionally add special circuits into the design, and the only purpose of these circuits is to make the chip easier to test later on. They're kind of like built-in inspection hatches and diagnostic ports that let the testing equipment see deep inside the chip's guts.
All of this, the blueprint checking, the physical inspection, designing the chip so it can even be tested, it all adds up. It's a truly staggering amount of work that, as a consumer, is almost completely invisible to us. Get this, for a modern, complex chip, some estimates say that up to 75%, 3/4 of the total engineering effort, isn't spent on the creative and initial design part, it's spent on verification and testing. 3/4 of the entire project is just making sure that thing works perfectly. And the standards they aim for are just unbelievably high. The quality of a test is measured by something called fault coverage. Basically, what percentage of all possible things that could go wrong can your test actually find? And the goal here isn't 90% or 95%, it's over 99%. This relentless pursuit of perfection gets them to a final quality level that they measure in ppm, or parts per million. For most chips you buy, the target is often less than 500 ppm. Think about that. For every million chips that pass all the tests and get shipped out, fewer than 500 will have some kind of hidden flaw. And that right there is the whole point. This massive, invisible effort from these two guardians, verification and testing, that is the reason that the billions of components inside your phone, inside your car, inside your computer just work almost perfectly every single time. It's the hidden bedrock of our entire modern world. It really makes you wonder, doesn't it? What other unseen, unbelievably complex systems are out there, quietly making sure our world works? What other invisible guardians are protecting the tech you use every day?